I'm Danyang Li. I'm going to make a final presentation on my paper. My topic is fuzzy search in information retrieval. So it is the test matching field. So what is the fuzzy word search? That is a technique of finding strings that match a pattern approximately rather than exactly. So what is the use of the fuzzy search? There are several very useful relevant applications use of this technique, like the spell error check applications, or some tasks need to detect the duplicate word. And there is also a very interesting use case, like in some big travel agencies. It provide it have some room types. Maybe one agent called this room type is Studio One King Bed with sofa bed corner. The other one may be called the same room type like Corner King Studios. And for the users, if you want to compare the price or the other information from the different travel agents, you need to make sure you compare apple to apple. So in these situations, so the fuzzy word search can help you to do that. So there are several algorithms can deal with the fuzzy word search. So the most common algorithm is added distance. So it's about to compute the minimum change of insert, delete, substitution between two words transformation. For example, the distance between book to back is 2. So that means there are 2 steps you can change from book to back. You need to change the first O to A, and then you need to change the second O to C, and the distance is 2. Another popular one is statistical algorithm, and one of the good one is a cosine similarity. But for apply for the test data, you need to change it to numerical vector first. And also there is a very interesting one called Sondex algorithm. It computes the similarity for the words with the similar sounds. So these three are very significant for this paper. I will focus on this and made some experiments on test data to compare the similarity score and find out the fuzzy word test processing for which algorithm is the most fitful one. And next is about the literature review. So I did some research on some papers, and learned some useful knowledge for the fuzzy search. The first paper is called a fuzzy approach to approximate string matching for test retrieval in NLP. So because for this paper, it focused on the added distance, and the author found out the difficulty of use the added distance for the purpose of the test retrieval. So it proposed a customized algorithm, which is introduce a matrix that will be update for each overlap character between two strings, and the degree of similarity is calculated by a ratio which use the counter in the matrix. So the reason I chose this paper is covered even the topic is more narrow because it's only cover the added distance, but it shows a very popular and because it is a very popular and well fitted one. So from this paper, I can refer from it can provide a better way to identify the similarity using a matrix to help us to improve the efficiency of the algorithm. And then next paper is robust and efficient fuzzy match for online data cleaning. So the data warehouse cleaning and validation is a very important steps. And for this paper in this link, the author proposed a new similarity function which overcomes limitation of commonly used similarity function. And develop an efficient fuzzy match algorithm. So they generalize the edit distance similarity by using the notation of tokens and the importance to match the input tuples with clean tuple from a reference relation. Then adding the index, which is error tolerance, to increase the efficiency of the edit distance algorithm. So from reading this paper, I have learned about relevant way with my project, especially in the information retrieval field. And this paper gave a very specific step for processing the test. And the third paper is the string matching algorithm research tool. So it talks about a string matching and it introduced a new smart string matching algorithm. It's a new version. It can provide a very flexible framework, and it can develop, test, compare, and evaluate the string match. And it also provides a testing environment. You can add in several new algorithms without compiling it. It's very good for to do the comparison between the several algorithms. So that's the main reason I choose this paper. So and also there is a couple useful paper I refer, which one is personalized fuzzy text search using interest prediction and word vectorization, and also a fuzzy semantic sentence similarity measure is not only about words but also a sentence similarity measure. And another paper about do the fuzzy search in a large text collections. And also some deep structured semantic models for the web search. Now let's talk about the research hypothesis for this paper. So because fuzzy word search is a very popular topic and it can improve the ability to find a matching word. So for this topic, I'm going to find the algorithm to deal with fuzzy word test and find the different situation and find the most accurate way to apply for the different situation. So there are several commonly used methods I'm going to test. One is the common keyword. To be specific, it's a Sondex. The other one is edit distance. Then the statistical method, to be specific, that will be the consign similarity. The research method choice for the research, most of it is quantitative and mixed with a little qualitative. And I will make an experiment on those three algorithms I mentioned below above. And because it's a test data, I will perform a test analysis like word frequency and the inner product and the Euclidean norm to and also will draw some histogram plot based on some word frequency to show the distribution. Did some topic analysis, and because the data is not very large, and I will also provide a human with some experience can see and compare some percentage accuracy to decide if the algorithm fits for the data. So now let's talk about more about more about the data. The data source is from Susan Lee's GitHub, It is about two sets of similar room types. One source is from Expedia, another one is the matched resource from the booking. So although they are you can see from the screenshot of the data, although they may be the expression is a little different, but they are referred to the same thing. Now let's talk about the data analysis. First step is clean the test. I use the Python language and use the Jupyter notebook, import these libraries and read the data. And then first clean the test data to remove the punctuation and change to the lowercase. It become to here. And then draw the histogram to see the distribution of the data. First, I sort the data value by name to check if there is a specific repeated value. You can see this is the data from the Expedia, and this is a histogram from the Expedia resource, and this is a histogram from the booking resource. There is only three value that the count is more than one, and for this resource is only two value the count and more than one, and there looks like no outliers, and the same with this one. And then I think it will be helpful to visualize the distribution of the word counts. So then I draw a second histogram comparison. The length in word this is the length in word for the Expedia, and this is the length in words for booking. You can see the distribution is not the school is not the same with those two resources, but the distribution of the number looks like similar. Like this is the smallest one is 1 and the lowest one is like 13, and the largest one is like 13, smallest one is like 2. And then we can see this, we will see some numbers. First, let's look at the average number of words in which value and the longest and the shortest value in our data set. It's the word count number of average for the resource Expedia, and the max value and the minimum value. Here is the computation for the booking. So looks like the max value and the minimum value is the same for both resource, and for the average, the Expedia ones have the a little bit bigger, larger than the bookings one. Let's look at the most common words over the entire corpus. First, we need to remove the stop words to be more accurate. Then I use the Python counter method to get the most common top 20s. So here is the code for the method, and here is how to remove the stop words. Then this is the result for the Expedia resource. We do the same thing for the booking resource. So here is the result. After we get the result, we can see that even the top one result is not same. The one is room and the other one is king. But look, the top 6, the room, the bed, the king, the room, the bed, the king, the view, 2. So they are all the same words, and the count is pretty similar. So and look at all the top 20s. The words looks pretty similar too. So that means the corpus is similar with each other. The next step is I will going to test the validation of the text data. We already draw the histograms and do the most common words check, and then we need to make assumption. For this data, look at the data. There is some king luxury deluxury words, keywords. So for this assumption, I will check if the row contains a king or deluxury in the Expedia. Also, for the booking resources, the booking resource also contains those two words. I plan to create a new Boolean field, and for one resource, the Expedia resource, I will check which rows have the king or deluxury. If that have, it will return true. And here is the result. And for the other booking, we did the similar things. Return true if it contains king or deluxury. And then we compare the two results from each other. If the value is equal, that means they are match. That means they are both contains king or deluxury. If not, that means they are not a match. So the match, after I did this, I found the match rows is around 55, and there is 59 in total. So that means the percentage of the match rate is about 93. So it's close to 1, and the result is very reasonable. So after we did all those three analysis for the data, I can confirm that the data set after pre-processing with stop words removal and tokenization, it's good to use to do an experiment for different algorithm for the fuzzy search. Then that's then let's do the data explanation. So there is the flow chart of it. And the first, now let's do some the code processing. The first one is about the edit distance. I found a very useful package that's called fuzzy to compute edit distance. There are several options we can use. For the fuzzy method, the partial ratio, the token set ratio, and the ratio. So I made some tests and found the token set ratio return the greatest value. So I decided use this one. Then I apply this this method to the every row of the tokenized Expedia and the tokenized booking resource. And here is the score. And generate a score column. Then for the second method is the Sondex method. So there is a library called Jellyfish. So it can help me to get the result, get the encoded code of the sound. So here is how to use it and apply this method for every row of the Expedia resource and the booking resource. So here is the result for both of them. If the code is same, that means the result is true. That means those two are match. Then for the third one is cosine similarities. For this cosine similarity, I need to first construct a vector space, then convert string to the numerical vectors, then calculate the angle between the two vectors, and using this count vectorizer. So when I got the cosine similarity, it's a matrix. I need to get the reshaped matrix to get the value here. So this is the result for this. So after I got how to do that, I will apply this method to both resource, the booking resource and the Expedia resource. Then generate similarity result column here. Then that's after we got all the result, let's look at them. So sorted by the result. This is for the Sondex one. So look at the true appeared first, then all the others are the false. So by doing analysis, I found from the Sondex result table, it's only 30% is true and others are all false. And then let's look at the similarity one. Look at the result here. We sorted by the similarity. So that is a cosine similarity. For the cosine similarity, the method is the result is about 58%, more than 58% above 0.7. And now let's look at the added distance, which is the popular one. Let's sort it from that. You can see the score until here it's all 100s. So after the calculation, we can conclude that more than 92% of the result above score 7. So the result is very reasonable. So after the comparison of the three results, we can confirm that our hypothesis that added distance is the most appropriate and accurate result for the test data for fuzzy word search. So here is some discussion on the research processing. First is about remove the stop words. So I did remove the stop words and also did not remove the stop words. Looks like, especially for compute the most common words, I found the result is pretty similar. So, but if we do not do the tokenization, that will be very hard to processing the data. And second is, I think there is some discussion field for the similarity computation for the cosine similarity. So I used the Python library to convert a string to numerical variables, then calculate angle between those. Excuse me. And the count vectorization is the library. And from the paper, I learned there is another way to use the vectors to compute a numerical score, also using the matrix. Read the vector that have dimensionally equal to the size of vocabulary. And if the test data feature that vocabulary word, we will put a 1 in the dimension. Every time if we encounter that word again, we'll increase the count. So this algorithm, the concept of this algorithm I learned from the paper is pretty similar with the library I have used, so which turns out very useful and easy to use. And then I noticed the result shows a very low similarity score for the Sondex one. and I looked at some result of the Sundex one. You can see some are very pretty similar, but maybe the order is not the same, and then it return false. So I think the discussion here is for the next step. Maybe we could introduce some weight of a result, or introduce deeper look after we get a result. Not only depends on only true or false result returns. And for some expect field, we can also conclude this type of data is not that fit for using the Sundex algorithm. Detail of next step after we have the discussion and the research processing. I think in the future we can optimize the computation of a similarity score, especially for the numerical vector transformation. And for the cosine one, I think it's better to add more training data for it. And furthermore, I think we can test on more test the data focus on the sound. And after all this finished, we can maybe develop it into a spell check application, or apply the algorithm into a search engine to make more use. So now come to the summary part. So from all the experiment and the data analysis, we can conclude that for the edit distance, there is some advantage that the matches across languages and the script and offer greater precisions. And for the disadvantage, and it only relevant to organization name matching. And for the statistical similarity, the advantage is pretty similar with the at a distance, but the disadvantage is a slow performance and a high barrier to entry because it requires training data, and I need to adjust the features. For the one of the algorithm of the common keyword, the Sundex, is limited to the Latin-based language, and it reduces name to a key or code-based. So sometimes it only return the code. Maybe it's not easy to interpret. But it also have its distinguished advantage that it make the semantic match spelling centric method. Those is the advantage that the other two algorithm cannot do it. So in conclusion, if you need to do the fuzzy search based on the same pronunciation, the common keyword, common key method will be your best choice. And if you need to have a very high precision, and you do not have you need to have an easy used way to do that, and do not have a lot of amount of data, I think the added distance is a good choice for you. And if you have a training data and you need to have a very high precision, I think the statistical similarity, cosine similarity is good for you. So here is a reference, thanks to those authors provide more information for this topic. And here is the data table. And here is the statistic table for the word frequency I compute from the data. Here is a histogram table to check the word frequency count and the length in the word. So that's all. Thank you. Thank you. Goodbye.